Yes, good evening all of you. This is Upendra, Physics faculty. Welcome to Spark Academy. So today I am discussing about the concept of laws of motion, lecture number 2. So today I will concentrate on numericals based on the last week in the last class what I was explained in the concept. So totally NEET and JEE level questions. Let us try to check it how we have to solve those all numericals today. Right. Let us try to check it based on the given question. Question is there in front of you. The pulley is light and smooth. The strings are inextensible and light. The system is released from rest. Find the acceleration of each block, tension in the strings, and reaction in the pulley. How it is existed. Let us try to check it. So, to solve this problem, let us try to take this is the reaction, what I said to you. So, it is always acts away from the total system, away from the pulley. Now, three different blocks are connected to two different strings. I was used here two different strings, that is, one is connected to 2 kg block and 3 kg block. Another one is connected to 3 kg block and 5 kg block. So now, let us try to take in the first string, it is a small string. So when you take on this one, the tension is acts away from the 3 kg block and away from the 5 kg block. It is existed like this. So like this here it is existed. This is I am considering this is tension P1. And the next tension in the second string, here it is existed, that is P2 tension, what I am considering. I want to find out the acceleration of each block and tension in the strings, and we want to find out the reaction in the pulley also, right? So let us try to take free body diagram of first block. So free body diagram of 2 kg block I am taking here. Free body diagram of 2 kg block. Then first you have to take on 2 kg block, 2 kg block. Here I was taken. So let us try to check it. Sorry. So 2 kg block, the weight of the block acting in the downward direction, that is 20 Newton acting in the downward direction, and tension P2 is acts in the upward direction. So you know already the acceleration of the 2 kg block is existing in the upward direction. Acceleration of the 3 kg block and 5 kg block existed in the downward direction. So, in this case, the acceleration of the block, 2 kg block, is existing in the upward direction. Then here, let us try to write down net force acting on the 2 kg block. Net force acting on the 2 kg block. So, how you have to take on that one? Means T2, means tension T2 is greater than 20 Newton in this case. Let us try to take T2 minus 20 is equal to 2 into mass into acceleration. What it will do? So this T2 minus 20 is nothing but a net force acting on the 2 kg block. That is equation 1 and considering here. So next one, another block, it is 3 kg block I am taking here. So I am considering here 3 kg block I was taken. This 3 kg block is acting, the weight of the block acting in the downward direction, that is 30 Newton, and acceleration of the block actually existing in the downward direction. And another one, two different forces are acting because in the entire string, whatever 2 kg and 3 kg block it was connected, that contains an T2 tension, and it is experiencing another force, that is T1 tension also. So the T1 tension will act in the downward direction, means in this direction T1 is there, in the upward direction T2 tension is there. Means in the downward direction two different forces are acting, that is tension T1 and 13 Newton, both are acting in the downward direction. Then based on that one, so what about the net force acting on the 3 kg block? Means definitely in this case 30 plus tension T1 is 30 Newton plus tension T1 force, both are acting in the downward direction. Those two forces should be greater than to compare to the T2 tension. That's why the block is coming in the coming to downward direction. The block is coming to the downward direction. So based on that one, I will try to frame the equation. Net force acting on the 3 kg block means 30 plus T1 minus T2 is equal to mass into acceleration. This is 3 into A. This is equation 2. Now I am taking another block, that is 5 kg block is also existing. That is 5 kg block is the last block. Anyway, weight of the 5 kg block, that is 50 Newton acting in the downward direction, and the tension T1 is acting in the upward direction. Tension T1 is acting in the upward direction. Sorry, here I was taken, just wait, the tension T1 is acting in the downward direction for 3 kg block. So for 3 kg block, tension T1 is acting in the downward direction. Yes, I was taken correctly. No need to worry. Now, tension T1 is acting in the upward direction for the 5 kg block. This is tension T1, but acceleration is coming in the downward direction. So now, the net force acting on the block, again here you have to observe, this 50 Newton of weight is greater than to compare to the tension T1. That's why I will frame the equation net force acting on the block like this, that is 50 minus T1 is equal to mass into acceleration, that is 5 into A. 3 equations, third equation. Means 3 equations we got here. Let us try to write down the first equation here. T2 minus 20 is equal to 2A. So T2 minus 20 is equal to 2 into A. This is first equation. So 3 equations are there in front of you. So let us try to solve these 3 equations. Then you will get solution of the acceleration first of all, and you will get the tensions existing in the string also. So now let us try to solve 1 and 3 equations. Then solving means we have to try to add those 2 equations. Means T2 minus 20 is equal to 2A, and another one is an minus T1, this is first equation what I am taking, plus 50 is equal to 5. So when you try to add these 2 equations, what you will get, this is T2 minus T1 plus 30 is equal to 7A. This is equation 4, what I got by solving the 1 and 3 equations. 1 and 3 equations. Now let us try to solve second equation and fourth equation to get the solution. So let us try to write down 30 plus T1 minus T2. 30 plus T1 minus T2 is equal to, just wait, I will copy the equations. T1 minus T2 is equal to 3a. So that is equal to 3a. And another equation it is fourth equation minus T1 plus T2 plus 30. So minus T1 plus T2 plus 30 plus 30 is equal to 7a. So this is 7a. Now this is the first equation, second equation, and another one is a fourth equation. Let us try to solve those two equations. Means you have to try to add those two equations. Plus T2 minus T2 plus T1 minus T1 will get cancelled. Then you will get 60 is equal to 10 into A. Means 10 6 are 60. The acceleration of the entire system or acceleration of each block in the system contains an 6 meter per second square. 6 meter per second square. When you got an acceleration, let us try to take another equation. That is, you have to try to use first equation here. Directly you will get T2 minus 20 is equal to 2a. T2 minus 20 is equal to 2a equation. Let us try to substitute the acceleration a in this. That is T2 minus 20 is equal to 2 6 are 12. So what about the tension T2 in the second string? 20 plus 12 is equal to 32 Newton. So it is nothing but a tension T2 existing in the second string. Now let us try to take another equation, straight equation it is there. That is T1 minus T2 plus 30 is equal to 3a. All values are there except T1. Let us try to substitute T1 minus 32 plus 30 is equal to 18 you will get. So here anyway minus 2 remaining, so there plus 2, so then you will get T1 value is equal to 20 Newton you will get answer. So like this you have to frame the equation and let us try to solve the problem. You will get solution very easily, but at the time of adding the equations or subtracting equations means at the time of solving the equations, don't confuse. Let us try to concentrate more and try to solve it properly. You will get absolute answer, no issues at all. Then what about reaction in this case? Reaction of a pulley, how we want to find. Here only I will show to you how to find the reaction. Let us observe the reaction of a pulley existing in the third string. This is the third string. It was connected to the rigid support. It is a third string, small string it is. In this reaction force it is existing. So see, observe in this case, the reaction is existing in the upward direction, and this reaction created due to the pulley. So pulley contains another one. It is nothing but an tension. So pulley actually through the pulley you have to compare. Then you will get what about the tension? The second string was connected to the pulley. So that second string contains an tension T2. It is acts away from the pulley. Tension T2. It will act away from the pulley. So what about the content? Yes, Vivek. Very good. So what about the content? Observe through by using this figure. So reaction R is equal to 2 T2. 2 into tension T2. Because both tensions are acting in the downward direction, different sides, and the reaction it is existing in the third string, was created in the third string. That string it was connected to the pulley. So reaction in the string R is equal to 2 into T2. So 2 into T2 value, what I got here, T2 is nothing but an, sorry, how much I got T2? T2 is nothing but an 32. Let us try to take 32 here. So 32 that is equal to 64 Newton is the reaction in the right. This is the reaction existing in the fluid. Like this, you have to solve the problem. You will get easily. So actually, whatever free body diagrams are drawn here, that is for completely explanation purpose. So these are all complete calculation should be uh, make in your mind and implement in your paper whatever requirement means same equations that you have to represent on paper directly. So solving equations represent that one, but blocks no need. So here only you have to solve whatever given figure. Okay. So this is the process. And next type of question I was taken here. That is two blocks are connected by an inextensible light string. See, this is different. It is one is in horizontal and another one is an vertical block here. Is there. So 2M block is vertically hanging and it is pulling the M block. The M block is placed on the horizontal smooth surface. So two blocks are connected by an inextensible string. The string is passing over smooth light pulley as shown in the figure. Find the acceleration of the blocks and the tension in the string and the reaction in the pulley. How it is existed. Let us check it. How we have to consider the tensions in the string here, right? So tension is always acts away from the 2 kg block. Here only single string was used. That is the single string. One end it is connected M block and another end it is connected to M block. Anyway, you know about this one here. 2M block is greater than to compare to the M block, right? 2M block is greater than to compare to the M block. So that's why acceleration of the block 2M block will come in the downward direction. And another one also, you know, this M block will move towards the right. So right side, that is acceleration it contains. Alright. Now let us try to check it. This tension means entire string contains a single tension. Means the tension T acts away from the M block and the tension T, the same tension T acts away from the 2M block. So when you try to take an this is and a reaction existed inside the pulley here it is existed. So this pulley here it will act in this direction and this direction tension it is existed. So reaction existed inside the like this in the direction of right. So now what about this one? So the final step we will see that one. What about the reaction also? Because we want to find out the reaction part I want to explain you. For this question you have to listen carefully. Definitely you will understand. Okay. If you did not understand, again you have to ask to me, no problem. So to solve this problem I am taking here, let us try to take free body diagram of 2M block. So I am taking 2M block free body diagram. This is 2M block and the weight of the 2M block is acting in the downward direction, that is 2mg. Alright. So mass into acceleration due to gravity and tension is existing in the upward direction for this one and acceleration of the block is existing in the downward direction. I am applying same concept. What about net force acting on the 2M block? So here mass is nothing but a mass of the block is nothing but an 2m, right? So weight of the block is 2mg. Definitely in this case, acceleration is in downward direction. That's why previous problem part I will explain, no problem. This is you have to listen. Once again I will explain that one also. Okay. So 2mg should be greater than to compare to the tension. Then now 2mg minus tension P is equal to this is it will give net net force acting on the 2m block. So this is nothing but an equal to mass into acceleration due to that. Right? So this is 2m, sorry, here it is mass into acceleration, that is 2m into a you will get here. This is first equation due to the block of 2m. And what about the m block here? So whenever I said to you already, whenever the block is in horizontal motion on a smooth surface, friction force is not existed. And another one, uh, block it is in horizontal, no need to consider about the vertical forces because weight of this block is balanced by the reaction force and normal reaction. So what are the remaining forces here it is acting? Tension T is acting in this direction. So acceleration of the block is also existing in this direction. So directly you have to write down for the free body diagram of the M block. So the net force acting on the block here is tension. Means due to the tension existing in the string, that's why block will move towards the right side. So tension is nothing but an force. So that's why tension is equal to mass into acceleration. This is the second equation. Substitute this second equation in the first equation. Second equation, let us try to substitute in the first equation. What you will get? 2 mg minus tension is nothing but a mass into acceleration, that is equal to 2 mg. So finally you will get 2 mg is equal to 2 mg is equal to 3 m into a. So m will get cancelled. So the acceleration a is equal to, means acceleration of the blocks in entire system is equal to 2g divided by 3. This is 2g divided by 3 you will get. Don't substitute the value of g because solution existing in terms of the g1. That's why I was taken like this. Then what about the tension in the string? Tension is equal to, you saw the tension is mass into acceleration. So in the second equation what I was taken, that is mass into acceleration. When you substitute this mass, you will get 2 mg divided by 3 you will get. So this much of tension is existing in the string. Okay, better. So now let us try to think about the reaction force in this case. So when you taken the reaction force, the pulley is existing like this. The pulley, the one string is connected to the pulley like this it was connected. So because of the tension, so tension is acts away from the pulley. This side tension will act away from the pulley. So automatically reaction force is existed in this direction. But oppositely, another force is also acting because the two tension forces like this they are acting, like this they are acting. This is downward direction. This is left side of the direction. So both are acting perpendicular to each other. Then what you will get? So this resultant tension force you will get actually when you try to calculate this one. So root 2 into T you will get. Root 2 into T you will get. So automatically reaction force is existing in the opposite direction of the resultant of the tension force. So this reaction force it is balanced by the root 2 into tension, means resultant of the tension force. That's why reaction is equal to root 2 into tension T here. So the net force here it is equal to 0 because both are balancing each other. Then root 2 into tension is nothing but 2 mg divided by 3 you will get answer. So root 2 into 2 mg divided by root 3. So reaction is equal to like this also you have to write 2 root 2 mg divided by 3 Newton is the reaction force of this one. Root 2 how you got. So apply this one directly. Resultant of the vector. How you have to take on resultant of the vector? R is equal to 2 vectors acting perpendicular to each other. How you have to take on resultant? That is resultant R is equal to So two vectors are acting perpendicular to each other. Like this it is there for example. So tension T, tension T. Both are vectors acting perpendicular to each other. Then what about the resultant? Resultant R. So not it is reaction, it is resultant. Okay. So resultant R is equal to square root of P square plus Q square plus 2PQ cos theta. This is formula you know now in the vector. So R is equal to square root of, this is a P vector, this is a Q vector. So this is tension T square plus tension T square plus 2 into T square. So because 2 into T square cos 90 degrees because both are acting perpendicular to each other. Cos 90 degrees entirely it is 0. So R is equal to how many 2 T squares, how many T squares are there? That is 2 T square. T you have to take an outside. Then root 2 into T you will get. This is the resultant force acting resultant force acting in this direction. So because of the pulley staying in the rest position, then reaction force acting in that direction. So the resultant is equal to the reaction force in the pulley. So both are balancing each other. That's why R is equal to root 2 into tension T. I hope you understood Vivek. Right. So the same thing you have to apply for the previous problem also. So let us try to think here. So this is the pulley. Right. I will try to take weightage. See this one today. So let us try to take this pulley. So for this pulley, the string it was connected, one single string it was connected actually. In the string, the pulley is now object. The tension existing in the string it is 2 to 10. T2 tension means it was connected 2 kg to 3 kg, right? Means the tension T2 is acts away from the pulley and this side also will act away from the pulley. And this pulley is connected to the rigid support like this, means this is the third string. In this string also tension force it is existed. That tension force is acts away from the pulley, that is we have to take a name reaction. So reaction is equal to how many T2s are there? 2 T2s are there. So that's why reaction is equal to 2 into T2. I hope you got an idea. Vivek, you got an idea right now? It's okay. Thank you. Alright, next question. Let us try to check it the next question. So this is also very good question. So very good question it is. The string are inextensible and light. The pulleys are smooth and light. Find the acceleration of each block and tension in the string. So Umesh Kamal Khan, good evening. New student, I think. Very good. So there is in this problem also you have to try to solve by using the free body diagram. So don't get any tension. आराम से apply करो. You will get definitely better idea how to solve the question. Right? So more chances are there to get the questions like this constraint equation based questions. Here I am discussing with you today smooth pulley and smooth surface only I am discussing with you. In the next YouTube live session, I will try to discuss with you with friction. I will discuss. That will also more chances are there to get the questions in NEET and EAMCET level program in JEE. Let us try to think what about the forces acting on the 5 kg block, let us try to check. 15 Newton acting in the downward direction. For 3 kg block, 30 Newton acting in the downward direction. Anyway, two strings it was connected to the 2 kg block. Two strings it was connected to the 2 kg block. So the tension T1 existing in one side and tension T2 existing in another side. So you understood this one. This is a 3 kg block. This is a 5 kg block. Definitely the acceleration of the 5 kg block will existing in the downward direction. So 3 kg block will move in the upward direction. By defaultly, the acceleration of the 2 kg block is existing towards the left side. This you understood, I hope. So now the tension T1 is existing in one string. I will try to take an 5 kg to 2 kg block. Tension T1 is existed. It will act away from the 5 kg block, and this is the same T1 tension. It will act away from the 2 kg block. And T2 tension, it will act away from the 2 kg block. The same T2 tension, it will act away from the 3 kg block. So this is the representation of the symbols in your block diagram. So whatever diagram you given in that diagram. Now you have to take a free body diagram. I will take first of all 2 kg block. I am taking 2 kg block first of all. Sorry, I will change the color. Right, this is the 2 kg block what I am taking here. So this is tension T2 and another one is a tension T1 here. And acceleration is acting away acting towards the left side. So then what about the net force acting on the particle? In this case, you know tension T1 is greater than tension T2. Sweta, door open check, heart వచ్చేస్తుంది. T1 is greater than T2. Getting a second. T1 is greater than T2. Now, so here let us try to form T1. So T1 minus T2 is equal to mass into acceleration, that is 2a. This is the first equation. And let us try to take this equation. So 3 kg block, I don't want to draw separately. Here you have to observe 3 kg block, 30 Newton acting in downward direction, tension T2 acting in the upward direction. Now you have to frame equation for the 3 kg block separately. Then definitely in this case tension T2 is greater than to compare to the 30 Newton of the weight. So this is T2 minus 30 is the net force acting on the 3 kg block, that is equal to mass into acceleration, that is 3 into A. So the same way similarly you have to apply for the 5 kg block also. For the 5 kg block, when you try to take an weight, in this case it is more greater than to compare to the tension T1. That's why acceleration is coming towards the earth, right? So that's why, so 50 minus T1 is equal to 5 into A, mass into acceleration. This is the third equation. So like this, you have to frame the equation. Then you have to try to solve this one. You will get answer. I will try to solve as much as fast. First, you have to try to solve 2 and 3 equations. That is, T2 minus 30 is equal to, T2 minus 30 is equal to 3A. So 3A, and another equation here it is minus T1 plus 50 is equal to 5A. Minus T1 plus 50 is equal to 5A it is. Let us try to add these two equations. What you will get? So T2 minus T1 plus 20 is equal to 8A you got here. This is the fourth equation you got. Now this equation and whatever the first equation is there, that's we have to try to solve. First equation here is T1 minus T2 is equal to 2A. So T1 minus T2 is equal to 2A here it is there. Okay. So now you have to try to solve entirely. This is T2 minus T1 plus 20 is equal to 8A, and another one is an minus T2 plus T1 plus 0, there is no value, no constant value here, that is equal to 2A. Now you have to add these two equations, plus and minus, negative and positive will get cancelled here. Then 20 is equal to 10A you got here. Then 10 2s are 20. You will get acceleration value is equal to 2 meter per second square. 2 meter per second square. Then you know you have to substitute the values of A in this case. You will get the answer. So T1 minus T2 is equal to 2A. A value is nothing but a, so 2. Then you will get T1 minus T2 is equal to 4, and we have to check it and substitute the values in this case. Let us try to solve this one. So T2 minus 30, for example, here you have to take T2 minus 30 is equal to 3A. Then T2 minus 30 is equal to 3 to the 6. Then T2 is equal to, you will get 36 Newton. So this is 36 Newton I got here. Okay, like this you have to substitute the value, and T1 also similarly you have to substitute all the values. Check it, this one, this only, T1 is equal to 40 Newton, you will get answer. 40 Newton you will get answer. So this is the process how to solve the numericals in the constant equation when at the time of blocks are existing on the smooth surface with a pulley connected, right? So this is the process. Now let us try to check it. Another type of question here it is there, that is blocks are connected to the pulley and it is an inclined plane. Anyway, this process based question I will explain to you in the next class, but here I will complete the concept in this case. For example, let us try to take only one block is there like this. Right? Anyway, two blocks are there here. Tension T1, he taken tension T2, it is acting away from the block. Tension T1, it's also away from the block. Instead of taking two blocks, let us try to take one normal picture here for better understanding for this one. So let us try to take, this is inclined plane. So let us try to take angle theta, here it is existing. Now let us try to connect this one, the two blocks with certain pulley, here it is there. This is certain pulley. I show disturb check. So now the block is connected on the system and it was connected the pulley like this, right? This is pulley like this, it is there. It is M block and it is 2M block, here it is there. Okay, this is 2M block and that is M block, here it is there. Then I want to find out the acceleration of the block in this case. So let us take on the free body diagram and try to find out what are the net forces acting on the block actually. So in this, the tension is away from the M block. Anyway, the tension is away from the 2M block also. Because of the 2M, there is no problem. Because 2M block, it is experiencing the net weight, that is 2 mg acting in the downward direction, and tension T1 is acting in the upward direction. Anyway, acceleration, let us try to consider existing in the downward direction. Then what happened in this case? What about the M block? M block existing on line like this in this shape. So now weight of the object, it is always acting in the downward direction, that you know. So this is the weight of the object. This mass is M and G. So weight of the block is acting in the downward direction. But normal reaction is always acts normal to the surface of the block. So sorry. surface of the block. Now the block existing normal reaction in this direction. This is now this one means mg will be resolved into two components in this case. So let us try to take this is angle subtended. This is mg cos theta, and another one you have to take on this one, another one. This is acting in this direction. This is mg sin theta is acting in this direction. This is mg sin theta. So two components. I was resolved weight of the object in the two components, that is mg cos theta and mg sin theta. So the acceleration of the block existing in this direction, let us try to take an assumption. This normal reaction is equal to mg cos theta, because mg cos theta is acting opposite direction of the normal reaction in this case. Means it is balancing, means mg cos theta weight means component of the weight of the object, one of the component cos component is balancing the normal reaction. So that is one equation I got here. So this is the vertical forces acting on the block. Then what about the horizontal forces? This tension T1 is acting that direction. This direction, another one is acting, that is mg sin theta is acting downward direction. Right or not? Means tension T1 opposed by the another force, that is component of the mg, component of the weight of the object, that is mg sin theta, sin component, right? So that's why how to frame the equation for this one means acceleration is existing in this direction, means definitely tension is greater than component weight of the object mg sin theta. So that's why I will take like this. This tension minus tension in the string T minus mg sin theta is equal to mass into acceleration. This is mass into acceleration. This is we got second equation. So when we another block it is also there, 2m block is there. When you try to frame the equation and try to solve that equation and this equation, you will get the acceleration what it is existing in the block. Anyway, in the next YouTube live class, we will discuss about different questions based on the inclined plane. So that is one session definitely I will take. Inclined plane questions are very interesting questions. We will try to discuss those questions in the next session. Thank you very much. If you want to join and take any course, means there Spark Academy providing NEET and JEE long-term and short-term courses. If you want to join, let us try to contact the Spark Academy. So numbers are existing on my screen. Let us try to check it and you have to contact with them. Thank you very much for giving the option. Thank you. In the next class we will meet.